Hello, beautiful people. It's been a while. It's been busy. Did you all miss my handsome talking face? Bet you did. I talked about making this video like 2 months ago, and I'm just now getting around to it. But better late than never. I'm actually going to be making a lot of videos coming up, just because I've had a lot of inspiration from the readings I've been doing. So I want to talk to you about bones, and I want to talk to you about bones and grounding. So yeah, bones. What's left of us when we die? We all look pretty similar when we're dead, don't we? It's easy to forget that when all the bones and all the flesh leaves us, we all look very alike. It's sobering and liberating to look at the bones of someone who's gone past this life and think, that's what my body will become. At least that's how I feel, especially in a place like the French catacombs, where you get to see this immense amount of human remains, skeletons, bones. To dust you shall return. I say liberating because, yeah, you're gonna die, and if that doesn't give you motivation to live, then I don't know what will. So enough of the cheerful stuff. Your skeleton is made of bones, 206 of them, the highest concentration being in the hands and the feet. It's common to see bones as these rigid, static absolutes that provide structural integrity and protect the organs, but it's easy to forget that bones are made up of living tissues, made up of cells, just like the rest of your body. And they belong to the matrix. We'll get to the matrix another time. And what are these bones made up of? Mostly collagen, which is protein, the most abundant protein in your body. In terms of protein composition in your body, collagen is going to make up about 1/3 of that. And there's different types of collagen, types 1, 2, 3, and so on, but we won't go into that. Just think of it as a building block. Makes up your skin, your hair, your nails, your muscles, your tendons, your ligaments, your blood vessels. Your bones makes up most of it, and because of that, it connects most of it. Lets things flow through it. And I'll tell you how in another video. It's gotten pretty popular as a supplement too. I know when I was injured in school, I would do lines of collagen, and I still take collagen. I just throw it in my bone broth for double the dose. But just because you consume collagen doesn't mean it's going to create more collagen in your body, because collagen is broken down into amino acids, and that can take a vast amount of different paths. So in bone, collagen provides a nice framework. You throw in calcium and phosphate, and you add strength and rigidity to that framework. Which, by the way, calcium and phosphate are both ions, so they have electrical properties to them. Your red and white blood cells are also produced here. Almost all your body's calcium is stored in the bones, the teeth. So you've got the combination of flexible collagen and strong mineral calcium phosphorus, which provides a strong but flexible framework. Bone, it's able to withstand stress, your weight, plus some. This is a nice analogy. I forgot where I picked it up, but think of your bones as bank accounts, so you can deposit and withdraw bone tissue. So when you're a kid, new bone is added or deposited faster than old bone is withdrawn. And so the bones become bigger and stronger, more dense. When you're older, your withdrawals start to exceed your deposits. So you end up in bone debt, which is weaker, fragile bones, osteoporosis. That's why it's important to take in calcium and vitamin D, which helps you absorb that calcium. And why it's important to stress your bones, put them under loads, weightlifting, not walking, it's not enough, resistance training. Mechanostat theory, your bones understand when they're under high mechanical strain and respond by initiating bone formation. It's picked up by these bone cells, these osteocytes, which send that information of high loading, mechanical loading, to your osteoblast and your osteoclast. This maintains skeletal homeostasis and allows the bones to remodel themselves, osteogenesis. So over time, your bones will become stronger, not so much bigger, but more dense. Density is important. It's what they look for in DEXA scans. So in order to get these osteogenic effects, you'll want to expose your bone cells to mechanical loading that goes beyond normal daily activities like walking. More specifically, there's a protein called sclerostin, which is central to bone formation. So mechanical loading will downregulate sclerostin, which would increase osteoblastic activity and decrease osteoclastic activity. And how you load your bones matters as well. You need the right magnitude, rate, frequency. Dynamic loading is known to be a lot more beneficial than static loading. And this is interesting. Your bones become desensitized and bored. And so you'll want to work them in intervals, or else they won't respond as well as repetitions become higher. So a set of 20 reps wouldn't be as effective as, say, 4 sets of 5. And you want to train them in multiple directions too, because your bones will adapt to unidirectional patterns. So let's get into bone pathology a little. So bone diseases and how those come about. So 2 of the big ones are osteoporosis and sarcopenia, which come about with aging. There's genetic predisposition, there's hormonal and mechanical factors like not exercising and not eating right. Osteoporosis, the bones becoming less dense, more fragile. Sarcopenia, accelerated loss of muscle mass. In much of the older populations, it's common to develop both of these conditions together. And because they're so concurrent, there's even a word for it. It's osteosarcopenia. Why are they so concurrent? It's because they're so closely interconnected, the muscle and the bone, anatomically, chemically, metabolically. And because they're so of this intimate connection between the two, we should look at therapies that target both the muscle and the bone together, like resistance training. So from a diagnostic standpoint, we would say that osteoporosis is the result of bone degradation, which means a decrease in bone mineral density. But the BMD, or bone mineral density, is the big one. So anything to that reduction in density can contribute to or cause osteoporosis. And what are some examples of things that can contribute to or cause osteoporosis? A lot of women out there already know this, but an estrogen deficiency, like what occurs in postmenopausal women, it's a lot more common in women because of the estrogen deficiency. So testosterone deficiency can contribute to osteoporosis too, but not directly like an estrogen deficiency does, because your bone cells don't have receptors for testosterone like they do for estrogen. And if you didn't know, we all have both testosterone and estrogen in our bodies. So why estrogen deficiency? So the estrogen receptor contributes to increased bone mineral density. So the deficiency of estrogen is going to lead to an increase in osteoclastic numbers and reduce apoptosis in these cells. So the osteoclasts are what break down the bone. The osteoblasts are what build up the bone. So because of this, there's going to be an increase in bone resorption, or breakdown of bone. And what's bone resorption? So throughout your whole life, your bones are going to constantly remodel themselves. They're going to get rid of old bone, resorption, in order to add new bone, ossification. And you want the right balance between the two, as with all things. So another thing, not taking in enough calcium. How much calcium you have in your blood is regulated by vitamin D, parathyroid hormone, ionized calcium, charged calcium. One thing that will happen when you're not taking in enough calcium is a form of hyperparathyroidism, which is going to boost the rate of bone remodeling so that you've got normal levels of blood serum calcium. When you've got an imbalance between the bone resorption, breaking down, and formation, that's going to accelerate bone loss. Going back to the banking thing we talked about earlier, taking out more than you're putting back into the bone. Vitamin D, that's another big one. Like we talked about earlier, vitamin D is what helps your body absorb calcium. The most hormonally active form of vitamin D, vitamin D3, dihydroxyvitamin D3, that's going to be the major controlling hormone on how much calcium you can absorb in your intestine, which is important because calcium is only available through what you can take in through your diet. And what are some things that are going to contribute to a deficiency in vitamin D? Well, obviously not taking in and making enough of it. And there are things that contribute to that, like obesity, because vitamin D becomes less bioavailable when you're fat, which makes sense because it's a fat-soluble vitamin. Not getting enough sun exposure, just getting old, because the older you get, the less you're able to absorb and produce. Hyperthyroidism can develop from a deficiency. So where can you get it? Your diet, dairy products, fish oils. Again, your body synthesizes it from the sun, so that's a big one. So there's lots of sources, so make sure you're getting in your daily dose of vitamin D and vitamin G. So other things that can contribute to or cause osteoporosis, physical activity, being lazy, not training your body, putting your bones under loads, stress, smoking cigs. There are other things that can, like conditions that can contribute to osteoporosis, like gastrointestinal disorders, which mess with your body's ability to absorb minerals, vitamin D, endocrine conditions that alter things like the gonads, hypogonadal states, which alter estrogen levels. There are medications that can contribute to osteoporosis, glucocorticoids, immunosuppressants, thyroid hormone. Thyroid hormone stimulates bone resorption. So how do we treat it, osteoporosis? Well, we already talked about a big one, which is resistance training. mechanically loading your bone tissue, getting in more calcium and vitamin D in your diet. Another thing with vitamin D is it's going to help with the synthesis and expression of calcium transporters in your kidneys and your intestines. Hormone replacement therapy is pretty common to see. But yeah, the estrogen receptor is found on a lot of the cells involved in bone metabolism. The alpha estrogen receptor found on the cortical bone tissue, so the hard outer layer, and the beta estrogen receptor found on the cancellous bone tissue, so that spongy inner bone. A few other things, biophosphonates, SERMs, or selective estrogen receptor modulators, like those prescribed to postmenopausal women. So those are cool and all, but you'll want to shoot for the natural remedies first. The lifestyle changes, eating right, exercising. It's amazing the amount of things that can be prevented and reversed with just those two things right there. And I also think grounding can help, and we're getting closer to that. But so far we briefly touched on bones, bone cells, osteoporosis, and those treatments, but what I want to go back to is calcium, specifically calcium phosphate homeostasis. You will be hard-pressed to find anything going on in the body that doesn't involve calcium. It's extremely important, it's critical for life. It's fourth or fifth most abundant element in your body, from mineralization of the skeleton and bones to allowing your muscles to contract efficiently, blood clotting, transmitting nerve impulses, hormone secretion, and most of it's going to be stored in your bones as crystalline hydroxyapatite. The other roughly percentage of it's going to be found in the blood, the muscle, the intracellular and extracellular fluid. In the blood, it's either going to be bound to a protein like albumin, which is the main protein in your blood. So bound to a protein or bound to anions, other charged particles like phosphate or citrate, or it's going to be found in its free or ionized form, which is going to be how most of the calcium in your blood is found. So calcium homeostasis is meant to maintain active ionized calcium in the blood within a tight range, and that's around 1.1 to 1.4 millimoles per liter. And that's crucial for all the functions of calcium that we talked about earlier. A lot of things can stem from hypercalcemia and hypocalcemia, but we're not going to focus on that right now. Phosphate, on the other hand, around 80% of that's going to be found mineralized in the bone, with the rest of it being an intracellular and extracellular fluid. The big hormones that control calcium phosphate concentrations in the blood are parathyroid hormone, which is going to increase concentrations of calcium in the blood, and vitamin D, which is going to do the same. And there's calcitonin, which is going to decrease calcium concentrations in the blood if there's hypercalcemia going on. So calcium and phosphate are ions, electrically charged particles. And these calcium phosphate ions, they have an affinity to the bone matrix for reasons not very well understood yet. So they'll deposit as non-crystalline or amorphous compounds, and after that they're converted to hydroxyapatite. Hydroxyapatite is the main crystalline salt of the bone. This is where ions are stored. It gives your bones the ability to compress. It's also going to act as this bank to draw on for all the calcium mediated reactions going on in your body. It's also going to keep your blood serum concentrations of calcium in check. So I did say crystalline a lot so far, if any of you are tech nerds out there. So the SoCals are brothers from Poland that have contributed pretty significantly to the research on the physiological and electrical benefits that grounding has on the body. And what they wanted to observe was how grounding affects the body, specifically the calcium phosphate homeostasis, as well as blood serum concentrations of iron. Iron overload or iron deficiency have been associated with weak bones, so it's important that that's kept within a tight range as well. But specifically, iron is going to influence your osteoblasts and osteoclastic activity in a way that's going to facilitate more bone loss. So they had 84 people in their experiment, 54 men and 30 women. And like most of these studies, they were grounded indoors with a copper ankle strap of sorts that was connected to the ground outside. And all they had to do was sleep. So they were randomly assigned to groups that would either be grounded or ungrounded throughout the night. So they took initial blood tests at 6 a.m. to have reference points for each subject. And that very same day, they began the experiment. So at 10 p.m., the grounded group was grounded and the other group remained insulated. And the very next day at 6 a.m., they took the blood samples again. They're also collecting urine in the experiment. So everything they did with blood, they're also doing with urine in terms of chemical analysis. So the analytical tools they used in this experiment were calibrated for serum ionized calcium, total calcium, inorganic phosphorus, and iron concentrations. So 8 hours of sleeping grounded, there was a lowering of serum iron concentrations, ionized calcium, total calcium, inorganic phosphorus, and alkaline phosphatase. So there was also a reduction in renal or kidney excretion of calcium and phosphorus. So reduction in calcium and phosphorus in blood and urine are directly related to osteoporosis. So everything they measured a reduction, enough to be statistically significant. So an interpretation of this, there's less of this stuff floating around in your blood, and you're not excreting or pissing it out. Well, where's it going? Well, more than likely back into your bone matrix, because like we talked about pretty extensively to begin with, these ions, these calcium ions, are exchangeable between the bone and the extracellular fluid. The bone is this pool of calcium phosphate salts that can be broken down and exchanged with the blood, and vice versa. And how much calcium and phosphorus you've got floating around in your blood is going to affect your nervous system, it's going to affect your endocrine system, so you see how delicately intertwined everything is when you alter something like calcium concentrations in the blood. So I suppose the question is, does grounding influence bone health? Well, it appears that grounding does influence bone metabolism and calcium homeostasis, which has an immense impact on chronic bone conditions like osteoporosis by pulling more extracellular ionized calcium back into the bone. So just like everything else we've talked about thus far, the blood, the brain, the heart, the muscles, circadian rhythms, there seems to be some sort of homeostatic effect that's occurring while grounded. And that's also observed in the skeletal system. So it would be interesting to see the implications of grounding in those with degenerative bone diseases. So I do hope there's some sort of follow-up to the study. Yeah, I mean, just one night of sleeping grounded reduces primary indicators of osteoporosis. That's pretty cool stuff. That's all I got for bones. I hope you guys found this stuff pretty interesting, as interesting as I do. I mean, I love reading about this stuff. I love telling you guys about this stuff. But this video was really kind of an introduction to get some other topics I wanted to talk about. So I'll be putting out a lot of videos in the next couple months on some really, really cool topics. So until next time.